Hi, this is your Lucky sir. Here are few questions, 25 questions from chemical kinetics and solutions. Which of the following reactions occurs at measurable rate? First one is neutralization very fast. Then this is precipitation reaction again very fast. This last option is very slow reaction. And hydrolysis of methyl acetate is your answer. The rate of a chemical reaction decreases as the reaction proceeds. If the first order reaction involves gaseous reactants and gaseous products, the units of its rate are atma per second, because rate is equals to change in concentration by time, gases change in pressure by time. For the reaction A gives rise to B, concentration of A decreases, concentration of B increases. So 1 and 4. The units of rate constant depends on order of reaction, zero order reaction if it is moles per liter per second, first order reaction per second, second order reaction liter per mole per second, third order reaction liter square per mole square per second. The rate of reaction depends on all, that is temperature, catalyst and concentration, except zero order. In your question paper it will be there, don't worry. The temperature coefficient of a reaction is the ratio of rate constants at two different temperatures differing by 10 degrees Celsius. K T plus 10 by K. T is known as temperature coefficient. Generally it will be 2 or 3. For a reaction, temperature coefficient is asking what is the temperature coefficient from 10 degrees to 100 degrees Celsius. 10 to 20 to 30 to 40 to 50 to 60 to 70 to 80 to 90 to 100. First, second, third, fourth, fifth, sixth, seventh, eighth, ninth. When 9 times you are increasing by 10 degrees Celsius, the rate increased by rate constant increased by 512. So what we need to think is 9 times and 512 is there. 512 will be the power of how much? That is 9 to the power of 2 is equal to 512. 2. The Arrhenius equation is direct question. K is equal to A to the power of minus EA by RT. Direct question. 2A, B and A to B. The reactant A will disappear at rates will be same. The same rate as B disappear. This will also become right option if it is appear. Okay, see carefully. The rate of formation of SO3 in the reaction 2SO2 plus O2 2SO3 is 100 gram per minute. Hence, the rate of disappearance of O2 is. From the equation, you can see 32 grams of oxygen when disappears, 2 into 80 grams of SO3 will be formed. They are asking about 100 grams of SO3. How much of this is? 100 into 32 by 2 into 80. 4 times. This is 5 times. 4 ones are 4 eights are. So 8 5 is 40 by 2. That is 20. Concentration of a reactant A changes from 0.044 to 0.32 in 25 minutes of time. The average rate of the reaction during the time interval is 0.044 minus 0.032 by 25. That is nothing but 4.8 10 to the power of minus 4 moles per liter per minute. A decimolar solution K4FeCN6 at 300 Kelvin is 50% dissociated. Then osmotic pressure of the solution is, osmotic pressure pi is equals to ICRT, where I is a Vanta factor that can be calculated from this data. Alpha is equals to I minus 1 by N minus 1. Alpha is 50% dissociated, means 0.5 is equal to I minus 1 by N is number of ions formed, 4 potassiums and 1 ferrocyanide, that is ferrocyanide part, that is 5 minus 1, 4. So I will become 4 into 0.5 plus 1. So I is 3. Simply don't think that K4FeCN6 is 5 ions, 50% means 2.5. Don't think like that. It will be coming 3. And when you calculate here by applying this formula, that is 3 into concentration is given decimolar 0.1, R is 0.0821. For PV is equal to NRT problems, we need to use 0.0821. Temperature is 300 Kelvin. If you simplify this, you will be getting 7.38. Vanta factor for 0.01 m aqueous solution of acetic acid is 1.04. The pH of that solution is, Vanta factor is given, I is equal to 1.04. So alpha can be calculated. Alpha is equals to I minus 1 by n minus 1. I is 1.04 minus 1 by n minus 1. Acetic acid dissociates into CH3COO minus and H plus. 2 ions are there, so 2 minus 1. So alpha is equals to 0.04. When alpha is known to you, you can go for, E is asking pH of the solution. So H plus concentration is equal to C alpha. C is 0.01, alpha is 0.04. So this is nothing but 4 into 10 to the power of minus 4. pH is equal to minus of log H plus minus of log 4 into 10 to the power of minus 4. 4 minus log 4. So something into 3, that is 3.4. 3 minus log 3 value is 0.4771. It will come around log 3.4. So answer is 3.4, sorry. 0.6 molar MgCl2 and 1.2 molar sucrose solutions are isotonic, then the degree of dissociation of MgCl2 is 0.6 molar MgCl2 means 0.6 into Vanta factor, we take I, that is equals to 1.2. For MgCl2, I value will be there. For sucrose, I value is going to be 1. So 0.6 into I is equal to 1.2 means I is equals to 2. When I is equals to 2, alpha you can calculate. Alpha is equal to I minus 1, that is 2 minus 1, by n minus 1, that is number of ions formed here are 3, 3 minus 1. 3 minus 1 is 2, so 1 by 2, 1 by 2 means 0.5, 0.5 means 50%. Consider the following graph plotted between the vapor pressure of two volatile liquids against their respectively mole fraction and select the correct option. See, here only A is there, B is 0. Here only B is there, A is 0. So here there is no B fraction, here there is no A fraction. Both A and B. Select the correct option for an ideal solution. For ideal solution, delta H is equals to 0, delta V is equal to 0, delta S is equals to 0. Okay, now, so all these are correct options, but not this. X moles of KCl and Y moles of BaCl2 are both dissolved in 1 kg of water. Given X plus Y is equal to 0.1 and Kf is equal to 1.85 Kelvin per molar. What is the observed range of delta T if the ratio of X and Y is varied? This is the wonderful question which I was saying about this in the class. See, X plus Y is equal to 0.1. You need to calculate delta TB. Then you will be getting the answer. Delta TB is equals to IKBM. And the answer is 0.38 to 0.53. Very, very important question. I will make a separate video on this. This place is not sufficient to solve this question. 0.1 m NaCl, 0.1 m urea. So first option, that is hypertonic. Hypertonic means more concentrated. Then BS, CPQ, and D purpose R. Correct order of osmotic pressure of the following solutions is NaCl is better because it is having 2 ions, 1 mole, 2 molar ions. 60 grams of urea, 60 by 60 means 1 mole. 34.2 grams of sucrose, 90 grams of. By seeing all this, you can say very clearly D must be great because D is having Vanta factor.